Alright, so this is a really quick video on the homework. So I'm going to just breeze through this. So they want us to name the strategy the child used, explain how they solved the problem and whether the solution was right or wrong, and choose the strategies that we think are best for the given story problem, and explain our reasoning. So for number one, the problem is when Sarah is 12, she's twice the age of her little brother. How old will Sarah be when her brother is 21 years old? So the first person, Sarita, uses scale factor. How do I know that? It literally says it here, right? Since Sarah is twice the age of her little brother, the scale factor between their two ages is 2. So she's using the scale factor to solve this problem. The only reason, or rather the only problem that's wrong, is that age doesn't represent a constant multiplicative relationship, right? So we spoke about that in class. So if I'm 10 years old and my brother's 8 years old, we're 2 years apart. Or rather, put it this way, I'll change that scenario. If my age is 20 and my brother's age is 10, right? Whatever year that is, yes, my age is twice as much as his. But once 1 year passes, my age is not going to be twice as much as his. Like, I'll be 21 and he'll be 11. And that represents a 10-year difference. So not only is Sarita wrong, but Mary is also wrong, right? Cross multiplication is a strategy that we use in solving proportions when we're trying to find a multiplicative relationship, but the idea is that it's not constant. Okay, so this isn't a strategy that works either. Claude's works. If Sarah is twice her brother's age when she's 12, then her brother must be 6. When her brother is 21, 15 years must have passed. Thus, Sarah will be 12 plus 15 equals 27 years old. So this is additive reasoning, right? It's taking into account the differences between their ages, which are constant, right? The differences between their ages is going to remain the same every single year. Okay, the relationship between the ages of two people is not multiplicative. Additive reasoning would be the best to use. So now we're given a different problem. In a free throw contest, Clifford made 9 out of 15 shots. Suppose Clifford's success rate stays the same. How many shots will Clifford make out of his next 20 shots? Well, just telling me that the success rate is going to stay the same tells me that the multiplicative relationship is going to be constant, right? It's telling us that it stays the same. So, anything staying the same or rate that stays the same means it's constant. So 9 out of 15, that's the same as 3/5, or I took 5 shots, I made 3 of them. I could scale that up and say, well, if I take 20 shots, then I should make 12 of them, right? It's the same rate. That's scaling up and down. Kevin, additive reasoning, right? 20 is 5 more than 15. So Clifford will make 9 plus 5, which equals 14 shots. This is incorrect, right? So for one, the difference between the total shots, like 20 take away 15, that doesn't mean that the difference between the number of shots he made will be the same. So Kevin is saying, well, okay, you took 20 shots, take away 15 shots, right? The difference is 5. So then what minus 5 will give me 9? Well, 14 minus 5 will give me 9. But the thing is, this doesn't take into account that this is a multiplicative relationship, right? There's a rate, and that rate is staying the same. Anytime you hear the word rate, it represents a multiplicative relationship. So his reasoning doesn't have any kind of multiplicative reasoning in there. Last but not least, Joey. So 9 divided by 15 is just like what we have over here, 9 over 15. And so what Joey did was Joey found the unit rate. 9 over 15, how many do you make for each shot? So once I find the unit rate, I'm just going to times that by 20. So the unit rate is 0.6 makes per shot, times that by 20, you get 12. So he's correct, right? The problem says, suppose Clifford's success rate stays the same, right? So it implies that there's a multiplicative relationship, and that multiplicative relationship is constant. So for this one, any of those strategies work. Any of the strategies we went over, except additive reasoning, that's not going to work. So problem number 3. 3 coffee mugs cost $24. How much would 18 coffee mugs cost if all the mugs cost the same amount? Okay, so we know that all the mugs cost the same amount, but what we also know is we can create a ratio, right? 3 coffee mugs to $24. And if I'm using the scale factor within strategy, then, right, I'm setting up a proportion, I'm lining it up, so mugs to mugs, and it's within units. So I'm looking for the scale factor within units, so from mugs to mugs. So how do I go from 3 mugs to 18 mugs? Well, I multiply by 6. Well, then I have to do 24 times 6 to keep the ratio equivalent, right? And 24 times 6 is 144. Same idea here, except it's across units. So I have the same ratio, 3 coffee mugs to $24. I'm setting up my proportion, right, mugs to mugs, except I'm going across units this time. So what is the multiplicative relationship across units? So from mugs to money, or mugs to dollars rather, well, it's times 8, right? 3 times 8 is 24. So then 18 times 8 is also 144. So difference, mugs to mugs within units times 6, mugs to dollars across units times 8. Right? I can figure out 144 both ways. Unit rate strategy per 1. How much does 1 coffee mug cost us? If 3 coffee mugs cost us $24, then 24 divided by 3 is $8 per mug. And I can times that by 18 to get $144 for 18 mugs. Scaling up and down, I know that 3 mugs cost $24, which means that 6 mugs is going to cost me $48, which means that 3 mugs, I can times that by 3 to get 9 mugs, so I can take 24 and times that by 3 and get $72. Well, 9 times 2 is 18, so all I got to do is take 72 and times it by 2, and I get 144. Pretty simple. There's a million ways you could do this using this strategy. And last but not least, well, almost last but not least, is cross multiplication. So I'm taking, right, my original ratio, 3 to 24. Should probably have written the units here, sorry. And this is dollars. Making sure I line them up correctly. With cross multiplication, I'm multiplying these two. So 24 times 18 is 432. And now I need to divide that by 3, and I get 144. Okay, so which strategies were most efficient for solving this problem? Well, that's going to depend on the person, right? Some people might like scaling up and down more. Some people might find, well, just give me the unit rate and I'm good from there. Some people like setting up a proportion and finding the multiplicative relationship within units, right? Some people like finding it across units. So that is going to vary depending on your personal preference. If you have any questions, just let me know.